This is lesson 4, exercise 5E, matrix multiplication. The learning goal is to look into the process of matrix multiplication, look into the real life context of a situation and apply matrix multiplication to it, and look into if a matrix multiplication can be defined. The success criteria is to be able to apply the required skills to successfully complete a matrix multiplication, just like I successfully completed that sentence, and to see if a multiplication can be completed based on its order. The transition between lesson 3 to lesson 4 is by far one of the most trickiest transition to do. And the reason why is because scalar multiplication is considered one of the easiest type of multiplication when it comes to matrices. But then we're going to look at the polar opposite of matrix multiplication, which is not as simple as you think it is. It's not like when in addition where you can just add these two matrices. If the order is the same, you can just apply those same concepts with matrix multiplication. And it's a bit misleading because you think, oh, matrix multiplication, it's just the same as matrix addition or subtraction. It's been coined this unfortunate term. I don't think it's matrix multiplication, although there is multiplication involved with it. There's a completely new process which can be considered confusing. So there's a lot to digest, and this is going to be quite a long video, but we'll look into this. We can tackle this together. So multiplying matrices, it's not a simple multiplication. It's important to remember that in general matrix multiplication, this is a very important rule, it is not commutative. That is, A multiplied by B is not the same as B multiplied by A. In other words, what this is saying is the order in which you multiply matrices together is very important, and it can only be defined in a certain way. You can't just flip these around like in the normal multiplication rules and expect the same answer or expect an answer at all. So it's easy for me to do 1 times 2 in real life is the same as writing 2 times 1. I can swap these around and this is fine. This is what we call commutative, and this works with addition as well. Doesn't necessarily work with subtraction and division, but definitely addition and multiplication. But in the matrix world, the same rules don't apply. So the method of matrix multiplication can be demonstrated by using this practical example here. The number of CDs and DVDs sold by 2 people, Fatima and Gaia, they're recorded in matrix N. So here we have matrix N, Fatima and Gaia, and this is how much CDs and DVDs they have sold respectively within a sale, 7.4 and 5.6. Now you can see it's been specifically highlighted in green for CDs and red for DVDs. The selling prices of the CDs and DVDs are shown by a separate matrix P. So these prices, obviously, this can vary depending on what we have. In this case, CDs, $20 and DVDs are $30. Now you'll notice that the order in which CDs and DVDs are on the top have kind of been inverted for the next one, and they've been put to the left here for matrix P. And this is very, very important because alternatively, this could have just been written as CDs and DVDs on the top with the $sign on the side. But it's very important that it's been written in this way. So we want to make a matrix, which is called S, that shows the value of the sales made by each person. In other words, if Fatima has sold 7 CDs and 4 DVDs, and the cost of each of the CDs and DVDs are $20 and $30 respectively, all we need to do to find out that price is, well, we can just get, if she sold 7 CDs, just multiply 7 by 20 to get its respective price. And then also multiply 4 by $30 to get its respective price. And with these two amounts, we just add them together, which is what this sentence is here. 7 CDs at $20, 4 DVDs at $30. That's just 7 times 20 plus 4 times 30. But when it comes to matrix multiplication, what we do with this is to just write this straight away into one line for matrix S. We do this again for Gaia. The context of how much the CD and a DVD cost will still be the same, but the only thing that's different is how many CDs and DVDs Gaia sold, which is 5 and 6 respectively. So same multiplication, we're just changing it to a 5 and a 6 for Gaia. And again, we're just adding the 2 different multiplications together to get the respective amount that each person got throughout their sales. So for this type of context, it makes sense because we know what we need to do. But it's tricky if without the context, I just showed, okay, here's the process. This is what you need to do. Just multiply this with this and multiply this with this and then add them together. It's a bit almost counterintuitive and random. This is the process. It's just a set of rules that have been made to help us with linear algebra. And linear algebra and matrix multiplication, or specifically matrices, go hand in hand together. And this is specifically the reason why. Just picture this type of context, but in a bigger type of setting. But we'll get into that now. We'll just look at the process. So as we move across with matrix n, which is the 7 and 4, how much fine I sold, we're going to multiply with each corresponding element that goes down in matrix P. So the number that goes across in n, which is 2, has to be the same amount with the next matrix that goes down in matrix P. So if we have, say for instance, another set of contexts, maybe CDs, DVDs, and tapes, and we have a third number that tags along in the end, we need that third number when multiplied to also tag along at the bottom of matrix P, because we then need to know the context of how much that is going to cost for each tape. Okay, so this is a very important feature, that the number that goes across, i.e. the number of columns in the first matrix, has to match the number of rows within the second matrix. It doesn't matter how many rows there are within the first one or how many columns there are. The amount of columns in the first matrix has to be the same as the amount of rows within the second matrix. So when we apply this, we've got 7 times 20, 4 times 30, and then add the two multiplicative results together. Let's write it for this one. This will be for 5 and 6. We don't have to write it, it's actually on the bottom here. This will be 5 times 20 and 6 times 30. So we're just applying the next row and then putting it down here. If this were to be another set of numbers, maybe 9 and 9, this was the matrix here. This is implying that there will be another person that has that we want to consider the amounts. But again, because the amount of columns that go across 1, 2 is the same amount of rows that are in the second matrix multiplication, in this case it doesn't necessarily matter. Okay, but we don't have to look into this now. We just want to see this process. You want to grab the first row and multiply it with each element within this first column, making sure that you add the multiplications as you go across. So 7 times 20 is 140, 4 times 30 is 120, 5 times 20 is 100, 6 times 30 is 180. When you add these two together, what you get are the results of how much Fatima and Gaia have received money-wise, respectively. So this is the best way to present this type of context, and more specifically the process of matrix multiplication. It can get tricky in regards to where to apply the approach, what you need to do. Before we get to a few examples, there is the set of rules that we have to consider that will make matrix multiplication easier to digest, and specifically what the results will be. So the first thing we need to consider for matrix multiplication is that for a matrix multiplication to be what's considered as defined, so remember, defined just means it can be equated or evaluated or doable, the number of columns within the first matrix, is what I was saying before, must equal the number of rows in the second matrix. So how we write this in general terms, if we have the first matrix, which is an m times n, not m times n, m by n matrix, the order of the second matrix can be an n by p matrix. And what you have to be careful is that whatever this number is within the first matrix, remember m and n can be any numbers, you gotta make sure that the amount within the second matrix of that order, these two have to be the same. It doesn't necessarily matter what this is and what this is. That's fine. These two need to be the same. So quick example, if we had a 3 by 6 matrix and we wanted to multiply this matrix by a 6 by 4 matrix, this is my M over here, and this is my N, and here's my N, and this is my P. I don't care what these numbers are, all I care about if these two numbers are the same. And because they're the same, this matrix multiplication is defined and it can be done. If these are not the same, they cannot be done, and it's not possible for it to be done. Now, let's say for instance that now we know that this can be done. The order of the product matrix, that just means what the results will be, what type of size or order the result will be when doing this multiplication. It's dependent on what these two numbers are to begin with. So if we have a 3 by 6 matrix and we multiply it by a 6 by 4 matrix, our result will be a 3 by 4 matrix. So there'll be 3 rows and 4 columns. That's our results. Whatever the numbers are within the matrix makes no difference. All I care about is if it's definable, if we can define, and what the result will be order-wise or size-wise. Okay, and that's what this little instruction means here. Now it is a lot to digest. Okay, we'll take this very, very slowly in regards to how we approach this. Let's look at this example over here. And this example says that we'll be looking at this process. It can be very tedious and error prone. It's easy to make mistakes. So we're just going to do very, very small examples, and you will see some small examples in the SAC that you'll be doing. But your graphics calculator can be used to do these matrix multiplications. So you can put a matrix within your ClassPad calculator and have your ClassPad calculator do it for you. When it comes to questions within the stack that you have to show the process, you will only get small examples. So here are 4 different matrices, A, B, C, and D. And we're going to do one of the 4 things. We're going to explain whether the matrix multiplication in each question is defined. We're going to see if the matrix multiplication, if it is defined, give the order of the answer of the matrix. We're going to complete the matrix multiplication if it can be done. And then we're going to check the answers on the calculator, which is what I'm going to show you how to input it into the calculator a bit later on. Now, before we even tackle these questions, the best thing to do is to write the order of each of these matrices here. So A, how many rows there are, is 3, and how many columns is 2. So this is a 3 by 2 matrix here. B, how many rows, 2. How many columns, 1. So this is a 2 by 1. How many rows, 1. How many columns, 1, 2, 3. So this is a 1 by 3. And D, how many rows, 3. How many columns, 1. So this is a 3 by 1. So these orders will help us dictate whether the matrix multiplication actually is defined. So A, we're going to do A, B. Remember, this just means matrix A multiplied by matrix B. So let's look at matrix A and get the order. So matrix A is a 3 by 2, and we're going to multiply this by matrix B, which is a 2 by 1. Because the two internal numbers are the same, matrix A, B is defined. We can do this. We can apply these what seems to be arbitrary rules of matrix multiplication, and we can define it, so we can get an answer from this. Now that we know that AB is defined, we're going to see if what the order of the answer matrix will be. So the order, or in other words, what the result will be based on these two numbers at the end of, at the start of A and at the end of B. So the order of product or result, I'm just going to put our result, is, this would be a 3 by 1 matrix. So in other words, when we do this matrix multiplication, I'm expecting 3 rows and 1 column when applied. So this over here, I'm just going to erase. Alright, I'm going to go ahead and now do the next step of completing the matrix multiplication. So A is 5246.3. So A is 5246.3, 4613. I usually have my answer sheet with me, but I don't have a printer at all. So I'm kind of have to rely on the other document that I've created, and B is 89. So AB, B being 89. So remember, the process goes like this. You're going to grab the first row within the first matrix, and each element is going to be multiplied by its corresponding row that goes across within the second matrix. So in other words, we're going to get 5 and 8 and multiply them together. We're going to get 2 and 9 and multiply them together. And we're going to add these results together. So AB, this is going to equal. So this is going to be 5 by 2. 5 by 8 rather. And 2 by 9, and this is going to be added together. So then 5, 8, 2, 9. We're then going to repeat this process, but we're going to go to now the next row, 4 and 6. So this is going to be 4 times 8, 6 times 9, and this is going to be added together. And then again, we're going to do it with the 1 and 3. So this will be 1 by 8, 3 by 9, and then again we're just going to add this together. So what I'm expecting is once all of this has been figured out, the order of the result should be a 3 by 1 matrix. Well, that will give me a 3 by 1. Once this is figured out, this will just be one number. There'll be 3 rows of them and 1 column. That's what I'm expecting. So let's quickly do some quick maths. Plus 5 times 8, 40, 2 times 9, 18, 4 times 8, 32, 6 times 9, 54, 1 by 8, 8, 3 by 9, 27. Yep, that's about right. Cool. Alright, let's get our results. 40 plus 18, 58. 32 plus 54, 5, 6, 7, 86, and 8 plus 27. And this is our result. And that's the matrix multiplication. Now it seems kind of arbitrary. You get from this multiplied together and we get this kind of wacky result here. It makes sense when there's context involved. As a arbitrary thing, this is quite random. Now I'm only going to show you this in one example. Well, I'm going to show you the second example as well, just to see if BA can be defined. I'm not going to do C times D. You can go ahead and check the answer board note solutions for that, because we are crunched for time. Before I show you the calculator part, let's just have a look at BA and see if BA can be defined. So BA is now going to be a 2 by 1 matrix, and this is going to be multiplied by a 3 by 2 matrix. So we're just grabbing this one and swapping them around. This here and this here are 2 different numbers, so BA is not defined. We can't do it. We can't apply the matrix multiplication rules to it. Alright, let's have a look at the calculator to see how we would put this in. Alright, within your ClassPad calculator, you want to go into the main setting. Once you're in the main setting, you're going to make sure that your keyboard is up. Remember, the keyboard button is in the middle of your calculator. For me, on the emulator, it's at a different spot. Now, we're going to stray away from what's considered Math 1, and we're going to go into Math 2 category or territory. And we're also going to use the ABC setting as well. So the first thing we want to do is we want to establish the matrix of A. Now, usually we would just write A is equal to and then put the matrix in when we're doing this on paper, but in the calculator language, we have to put the matrix in first, then associate it with the letter after the fact. So let's go ahead and put the matrix in. Click on Math 2, and within here there are 3 different buttons that you can see here. This button here, once pressed, will make you put in as many columns as you wish within the matrix. By default, it will always put a minimum amount of 2. There is no point putting just one matrix number in, because then you can just essentially just use a number by itself. The other button that we have here is the column button. Again, by default, it will always put a minimum amount of 2. Each time you press it, the amount of rows will increase. The next button, or the last button, is the square matrix button. Each time you press this, by default, it will start off with a 2x2 matrix, and every time you press it, it will increase its dimensions, a 3x3, 4x4, or 5x5, etc. So we want to put in matrix A. So matrix A is a 3x2, so we have 3 rows and 2 columns. So I want to make sure the amount of columns I have, the 2, and the amount of rows I have, 3. So I press this one once, and I've pressed this one twice. I'm then going to put each element into the required space, making sure that I use my cursor pad to establish these numbers. Don't press execute, just press across or down. Once you've filled out every single element for that matrix, you want to go across into the cursor is to the right hand side of the whole matrix itself, and you can tell because the cursor line increases in size. It doesn't look like that, but it looks like this. Now, we're so used to putting an equals, we're not going to put an equals for matrices. We never put equals with matrices. We actually use this button here, which is an attachment button. When we press this, we want to attach this to our letter. To get a letter up, we'll press the ABC button, and just out of consistency's sake, let's make sure it's a capital letter and put in capital A. Once we execute this, this will say, okay, this matrix has been established as matrix A. So every single time I press A and then press execute, it's going to say, oh, I know what A is. That's that matrix that you just told me it was before. So now that we've got A, we're going to go ahead and put in matrix B. So we're going to click the back button within the keyboard, go back to Math 2, and matrix B is a 2x1. So all we need to do is just click this second button here, put in 8, make sure you use your cursor, 9, go across until the cursor turns big, press the attach button, and this time we're going to do caps lock B to this. We have 8, 9. Now we've got that, we know that AB, or A times B, matrix A multiplied by A matrix B to be specific, is defined. So we're going to just put in A, make sure you press your multiplication button on the keyboard, it's going to look different on my emulator, B, and what you should get is a result 58, 86, and 35, which is the answer that I got here in the first place. If you go ahead and try to do B multiplied by A, this isn't going to be an answer. It's not going to work. So it's going to say invalid dimension. It's not defined. It can't be done. So putting it into the calculator is so much easier, matrix multiplication wise, in comparison to doing it by hand. That doesn't mean you can get out of doing it by hand. You do have to show this process within your SAC. You will get the hang of it after a bit of time. For now, I want you to go ahead and try example CD. You can use the answer sheet to help you out. You're going to check your worksheet to see which questions you need to do, and keep it under 25 minutes. I'll see you in the next video. Bye bye.